What it do, people? Welcome to your solution video for your extra practice worksheet that you received in class. Now, in each problem, I'm going to go ahead and show you up here in the top left corner what the answer is. And if your answer matches with what you have, then just fast forward along in the video until you get to the next problem. You can go ahead and watch how I do the problem because it might be different than how you did it. And seeing how to do a problem in more than one way definitely enhances your learning. Okay, so I don't want you just to automatically just skip through and see if you got all the correct answers. You know, if there are some of the tougher problems, you might want to stop and see, like, all right, let's see how Mr. G did them. Did he do it the same way I did, or did he do it differently? And maybe I can expose your thoughts to maybe a different way of doing a particular problem. So the first problem here, we have a parallelogram. And I know this chapter we haven't really focused on parallelograms, but it's just kind of a nice review. Okay? Now, the thing to remember about parallelograms is first that the area, if I wrote in a different color that wasn't white, is the area of a parallelogram is just base times height. But the base and the height had to be perpendicular to each other. So if we find that 90-degree angle, it's pointing to this piece and the 8. Well, how long is this piece here? Well, it's the same as the other piece that's on the other side that's opposite of it. So the base and the height are 8 and 6, and so 8 times 6 makes 48. And that was my answer up here. So what did the 10 really have to do with this problem? Absolutely nothing, just trying to throw you off. Number 2, the answer is 126 units squared. Now again, we just have a regular old triangle here. So chances are I'm probably going to try to use 1/2 base times height. But again, the base and the height must be perpendicular to each other. So find that 90-degree angle. Boom, right there. The 14's touching the 90 and the 18's touching the 90. That must be my base and height. So 1/2, 18 times 14 is 126 units squared. So again, what does the 16 and the 20 have to do in this problem? Nothing. It's to throw you off. Number, if it'll let me click. There we go. There we go. Number, maybe. Come on, work with me. Number 3. The answer was 45 units squared. So and here's where we're getting into more of the problems that we were doing in this chapter. Here's a kite, for instance. And if I wanted to look at this thing as maybe 2 triangles, or I could look at it as 4 triangles, it really doesn't matter. But I'm going to try to find the area of this entire top triangle because the entire bottom triangle is the same exact thing. So there's some extra markings that I really should have put in here for you. So for example, this piece, it'll let me do markings here. Come on, 3 markings. And this piece down here, these two are the same. So once we find one, we automatically know the other. So we know the whole base of the triangle, of either triangle, is 15, right? Because it's the 5 or the 3 plus 12. But we need to figure out what's the height in both of these. And both of these are the same. So can we use Pythagorean theorem? And no, we can't. We can't use Pythagorean theorem because I only know one side of each right triangle. I know this side's 3, and down here this is 3, and this is 12. I don't know this, I don't know that. I know that, again, this piece is 12. But the thing to note, the extra piece of information I gave you, was that these angles are marked congruent. And so if there's a 90 right here, the only way those two angles can be congruent in a right triangle is if they are both 45-degree angles. And so we have our 45. This thing will let me write. Come on. Come on. We have a 45, 45, 90. And so this is x, this is x. Come on, x. Come on, x. Come on. There we go. And this is x root 2. So the side we know is x, which is the main piece of the puzzle. So I can get rid of all this extra stuff here. So we know that the height must be 3, which means this piece down here is 3. So now if I do 1/2 base times height, then I'll have 15 for the base. I figured out the height was 3. I'm going to end up doubling this thing because I have 2 triangles. I have the one on the top that I highlighted in orange and the one on the bottom in red. And the 1/2 and the 2 are just going to knock each other out. So really I'm just doing 15 times 3. So the area is the 45 there. Now I could have figured out what the area of each individual little triangle was and added them all together and I'd still get 45. Or I could even look at it in terms of, say, the entire left triangle versus the entire, color here. The entire right side of the triangle. Now the areas of those will not be the same. We will just add them together in the end. Number 4, the answer was 240. Now on this guy, I've got a rhombus. And how do I know it's a rhombus? Because all 4 sides are congruent. Okay? So really I could go ahead and mark that all the other 3 sides are also 17. Does that really help me out, figure out anything? No. But another thing that I should have marked was that these 2 pieces are the same because the diagonals bisect each other, and these 2 vertical pieces are the same. So I know this is 15 over here. So now if I wanted to think about it in terms of, again, 2 triangles, maybe this big top one versus this little, or not really little, but this identical bottom one, I know that the base of the whole triangle here is going to be 30. So I got my 15 and 15. Again, I'm just missing height. Now, I can't really use trig because I don't have any angles to work with besides the 90, but I don't really need trig. All I really need to do is discover that I can use the Pythagorean theorem in this triangle. And so this ends up being a Pythagorean triple. It's not one we normally discuss, but it ends up being, if you do the math, if you want to check me here, it ends up being 8 exactly. So we can do 1/2 base times height, and that's going to give me 120. And then again, I could double that because I have 2 triangles, one on top and one on the bottom, and I get a whole area. This thing will let me write. Come on, let me write. Let me get a 0 in there. Oh, it got most of a 0. There we go. 240. Again, I could have looked at it in terms of there being 4 smaller triangles, and I could find the area of each and then multiply it by 4, and I still should get 240. Number 5, answer should be 74.1 units squared. Now, chances are, since we have a 60-degree angle, there's probably a square root answer that you could get as well, and we'll discuss what that is. So let's look at this guy. We're going to end up having a rectangle in the middle, and then we're also going to have 2 triangular ends that we can think again about kind of smushing together. Now, if this top part up here is 4, then this part down here is 4, which means that the other 2 triangular pieces, this piece and this piece combined, make 11. Okay? Do I need to know what they are individually? No, I really don't care. So I'm going to call that the base. I'm going to do a little sub-triangle there, is 11. The main thing I need to figure out for both the rectangle and the triangle at this point is what is the height. So if I realize this is a 30, 60, 90, this is x, this is x root 3, and this is 2x, the piece I know is the 2x, so 2x is equal to 9, divide the 2 over, and I'm going to get 9/2, or 4.5, which means the height is 4.5 root 3. And this little piece down here is 4.5. So I could figure out that this other little piece over here is what, 6.5? But again, who cares? I want to know what it is all together. So the area of the rectangle, the base is 4, the height is 4.5 root 3. So let's see, 4 times 4.5 is going to give me 18 root 3. And in the area of the triangle, 1/2, we said the base was an 11, and the height was the 4.5 root 3. Oh boy, so what's that going to come out to be? That's not going to be fun. I'm going to need a calculator on that one. Half of 11 is 5.5 times 4.5 is 24.75 with the square root of 3. So adding my 2 pieces together, since both of these numbers are square root of 3 numbers, I can take the 18 plus the 24.75. So the total area is 42.75 square root of 3 units squared. Now, if I were to do 42.75 times the square root of 3 in my calculator, guess what I get? Approximately 74.1, which was my answer up here. So anyway, the decimal answer or the square root answer is perfectly fine. Just depends on how you want to approach it. Number 6, answer is 175 units squared. Now, you were told that this is a regular pentagon, and regular means that all of the sides are the same. They're all the same length. And I gave you what one of the sides is. It's 10. So we know we could write in the other 4 sides, that was a crazy 0, that all the other 4 sides are also 10. Now, we took are bigger shapes, and we broke them down into smaller triangles. So we always went to the center, and we went to each vertex to make our smaller triangles. And our goal was to try to find the area of one of these little baby triangles. And look, we've got all the information we really need here. The 10 is the base, and the 7 is the height. So the area of a triangle, 1/2 base times height, that's going to give me 35. And how many triangles am I going to have in this pentagon? I'm going to have 5 triangles total. So 35 times 5 makes 175 units squared. Exactly. No rounding needed. So this is the ideal situation when I give you the apothem, which was the height of the mini triangle, and the side length of the whole pentagon, which is the base of each little mini triangle. Number 7, 81.7 is our answer. Now again, chances are, since I've got a 30-degree angle here, there is a square root answer that would also be acceptable. So let's figure out what that specific square root answer should be. So let's see, we probably want to draw in this perpendicular, perpendicular. So let's see, what else do I know? What else do I know? What else do I know? Well, I know the base of the rectangle 6. The height would be, well, really what these two pieces combined are. So I don't know how much that piece is, but once I know what that is, if I add 5 to it, that'll be the whole height of the rectangle. And this little piece right here, this question mark, would be, you know, the height or the base, depending on which way I want to look at it, of the right triangle. So this question mark piece is vital to figuring out not only something for the rectangle, but also something for the triangle. Now, if this is a 90 and that's a 30, this has got to be a 60, which means opposite the 30, this much is x. Opposite the 60, this is x root 3. And again, that's only going up to right here and down to here. It's not all the way across. And my hypotenuse is 2x. So I gave the hypotenuse, the 2x is equal to 10. So x, come on, work with me here. X must be 5. So this little piece is 5. Now, could we assume that this and this 5 were going to be the same thing? No, we could not have assumed that. So we know the whole height of the rectangle is 10, because again, the 5 and the 5. So the area of the rectangle is 60, 10 times 6. And then over here, if x was 5, then this piece over here is 5 root 3. And now we can find the area of this triangle. Here's the 90-degree angle. So the two pieces adjacent to it, aka the 5 and the 5 root 3, that's the base and the height. So area of the triangle is 1/2. Now, it doesn't really matter which one's the base and which one's the height. No, as long as I pick the 5 and the 5 root 3, that's going to be, what, 12.5 root 3? So the entire area would be the 60 plus the 12.5 root 3 units squared. I can't add the 60 and the 12.5 because the 12.5 is technically a square root of 3 number, but if I were to type all this into my calculator, this should come out to be the approximately 81.7 that I have listed up there. Number 8, your answer should be 104.2 units squared. Again, there's probably going to be a square root answer floating around in here since I see a 45 and a 60. So chances are I'm going to be using some special triangles again. So let's see, and this might end up being kind of ugly, but we'll see how everything works out here. Now you might ask, what do these mean? Well, those mean that we just have parallel lines. So this thing really is a trapezoid. Okay, it's not your typical looking trapezoid, but it ends up being what that is. Now, we probably want to draw in some heights. We want to draw one down here and maybe one down here. So let's see, what can we do? If we drew in heights, these are perpendicular, 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 perpendicular. So we've got a rectangle, and we have two triangles here, but this end has been kind of like twisted, right? But still, what we can do, I keep accidentally erasing those. We can still think about this as a rectangle with one triangle. We might just want to think about this thing flipped over, or we could just go ahead, since it's not really a nice looking thing, nice looking triangles to work with pushed together, we could just find the area of this guy down here and the area of this guy down here, and so we could add together these three areas total if we like. Now, where can we really start at in this problem? Well, the 8 root 3 represents these two pieces put together, and I can't assume that they're, split up 50-50. So the main place I get to start at is the 10. Now the 10 is a part of this 30, 60, 90 triangle. So let's apply the pattern and get some pieces. This piece down here, opposite the 30 is x, opposite the 60 is x root 3, and the hypotenuse is 2x. So I was given the 2x side, which is 10, so x is 5. So 5 just goes from here up to right there. The height is 5 root 3, which is going to help me out because I can slide it over here and say this is 5 root 3. Okay, so now what can we do? What can we do? What can we do? Well, we can't really still do anything with the rectangle. We know the height is 5 root 3. We're still stuck on the base. So this is where now maybe I can come over here to my 45, 45, 90 triangle. Well, if you remember the pattern is x, x, x root 2, this piece represents the x piece. Here is the other x piece from here down to here. So this is also 5 root 3. Now, will the hypotenuse really help me out in finding area? No. Now, if this whole thing is 8 root 3 and this much is 5 root 3, that means this leftover piece in our rectangle must be 3 root 3, because 3 root 3 plus 5 root 3 makes 8 root 3 altogether. Now we can start finding the areas of all of our individual pieces, because I think we've got everything here. So let's start with this triangle. This triangle would be 1/2 base times height. Its base we figured out was 5 down here, and its height was 5 root 3. So that's going to give me 12.5 root 3. So there's part of my answer. The rectangle. Base times height. Well, the base was 3 root 3 we figured out, the base up top there, times its height was 5 root 3. Well, the 3 times 5 can multiply together to give me 15, and root 3 and root 3 can multiply together to give me the square root of 9, which is 3. So really, that's 45. Now we've got the area of this other triangle. 1/2. Now the base and the height, there's my 90. So the 5 root 3 and the 5 root 3 serve as my base and height. So let's see. 1/2 5 times 5. I can multiply those out. 5 times 5 is 25, and half of that's 12.5. Now the root 3 and root 3 will multiply to be the square root of 9, which is 3. So 12.5 times 3 will be 37.5. So there are my three pieces, 12.5 root 3 plus 45 plus 37.5. And can I add any of those numbers together? And yeah, we can add the last two. We can add 45 and 37.5. Those are just regular old numbers. I mean, one of them's a decimal, but who cares? And that adds to be 82.5. Now, the 12.5 root 3, it's a square root number, so I'm not allowed to add it with the 82.5. So really, here's the exact answer. 82.5 plus 12.5 times the square root of 3. And if I were to punch out to my calculator, I'm going to get, rounded to the nearest tenth, this 104.2. So this one is, I guarantee, the toughest one out of the 10. Okay, because there was lots of little things you had to do in here. There were two different patterns going on. Number 9, regular octagon. We know the side length is 20. So let's break this thing up into its little baby triangles. Ba-boom. Now, we can also draw in the apothem, aka the height of the little mini triangle. Well, if it'll let me do it here. There's our height. We just need to make sure that we mark it as being perpendicular to the bottom base. And since both of these are radii and they're equal in the same octagon here, then we know our 20 is going to get split up 10 and 10. But we really need to figure out what's the height here. Now, what we could do is we could take the 360 that represents the 360 degrees going around the center, divide it up into 8 little sub-triangles, so each little sub-triangle is 45 degrees. But we split up that 45 when we drew in our apothem, or our height. So now we end up with, ooh, yuck, a decimal angle. Yep, sorry. So this little guy here is 22.5 degrees. Sorry for those little tails. I don't know what's going on with this thing. Can you get rid of your tail? Get rid of your tail. Yeah, close enough. Okay, so now we could do some trig here. I know the opposite side is 10. I want to know the adjacent side h. So we could set up tangent 22.5 equals 10 over h. This is a flip-flop problem. So h equals 10 divided by tangent 22.5. And let's see in the calculator, 10 divided by tangent 22.5 is approximately, to one decimal place, 24.1. So now I could find the height, or not the height, I just found that, the area of this little mini triangle. So the area of one triangle is 1/2. The base was our full 20 there, times the height of 24.1. So let's see, that's going to give me, well, 1/2 of 20 is 10, and 10 times that's just going to move the decimal point over 1. So it should be 241 if I'm not mistaken. And then let's see, times 8 altogether, because I have 8 triangles in this octagon. So 241 times 8 is 1928. Now, the answer I got of 1931.4, I must have used a different method that maybe approximates it a little bit better than my 1928, which is fine. Probably what I did, maybe I figured out what the radius was instead of the height, and then used the 45-degree angle with the side angle side area formula, and then multiplied by 8, and maybe that gets me something closer to 1931.4. So let's see, just real quick here. Boom, boom. Let me draw all the stuff back in. That was 10 and 10. Let's solve for the radius. This guy we knew was 22.5 degrees. So I know the opposite. I want to know the hypotenuse. So sine now, sine 22.5 equals opposite over hypotenuse, which I'm calling the radius. This is another flip-flop problem. So 10 divided by sine 22.5. 10 divided by sine 22.5 is 26.1 for the radius. So the area of a side angle side triangle was 1/2 side times side. So I'm just going to square the 26.1 times the sine of the angle in between, which was the full 45, not just the 22.5 anymore. Multiply that times 8 triangles altogether. So let's see, 1/2 times 26.1 squared times the sine of 45 times 8. And I actually get 1926.8 for this. So man, how did I figure that out? I don't know. See if any of you get 1931.4, because I know I've worked these out before. There must be some other way that maybe I didn't round. That's probably the thing. Maybe I didn't call this 26.1. Maybe I called the radius its original form of 10 divided by sine of 22.5. So maybe that's the case. Let me see. Half 10 divided by sine 22.5, square that, times sine 45 times 8, and there I get my 1931.4. Okay, so I didn't do any rounding. I left everything as ugly as it was, and so this is the closest to the exact answer as anything else. But if you got the 1926 or the 1928 I got earlier, you're fine as long as you show me your work and you don't round too crazy. The last problem, the answer is 219.5. Now, we've got a regular triangle here, and regular triangles, see, what's so special about regular triangles? Oh, they're equilateral, right? So we know that this side, and this side, well, they're all the same. And so but I was given what the radius was. Oop, come on, there we go. So each radius is 13. But here's the thing, I don't really care what the sides are, because what's looking nice here is if I take 360, which is this circle around the middle, around the center, divided by 3, each one of these angles are 120 degrees. Now this should stand out because boom, there's a side angle side. So I can find the area of one of these triangles, which is 1/2 side times the sine of 120. Now typically, we have never really taken the sine of an angle over 90 degrees, but it's okay for sine as long as it's less than 180, and I'm going to get approximately 73.2 for one triangle. Now times 3 triangles all together, times 3, and I get 219.5 units squared. Now I could have dropped down the apothem, I could have split up that 120 into 60 and 60, I could have figured out what half of the base was. To get the other half of the base, I could have figured out the apothem to get the height, and then found the area of that triangle through 1/2 base times height. But anytime they give you the radius, alarm bells should be going off in your head. Hey, let's try to use that side angle side shortcut formula. You just need to figure out the angle in between, and that's kind of easier, way easier, than figuring out what the side length of the base and the height or the apothem are. So that's all for this video. Hopefully you got all these, or you now maybe understand them a little better than you did before, so that we can take that quiz the next day in class. Adios.